Cybersecurity in the industrial environment. Protection of the OT area. Bastioned facilities. Routing techniques. In addition to classic routing techniques, NAT, net address translation, and PAT, port address translation, can be applied to increase device security. Routing refers to the process of sending data packets from one network to another through a series of network nodes or devices. Routing is a fundamental part of Ethernet-based networks, as it enables communication between devices on different networks. When a device sends a data packet to another network, the source router analyzes the destination address of the packet and determines the best route to send it. This process is based on information stored in the router's own routing table, which contains information about the networks directly connected to that router and the best route to reach them. Routing can also be used to provide load balancing and redundancy services. In load balancing, data packets are distributed across multiple paths to make the most of network capacity. In redundancy, multiple paths are used to ensure that data packets are delivered even if one path fails. Routing is done by using different routing protocols, which determine the best path to send the data packets. These protocols can be classified into two main categories: static routing and dynamic routing. Static routing involves manually configuring the routes on the routers. This means that the network administrator has to manually configure the routing information on each router. This type of routing is suitable for small networks or for routes that rarely change. Dynamic routing, on the other hand, is automatically configured by exchanging routing information between routers. Dynamic routing protocols, such as the IGRP protocol or the EIGRP protocol, allow routers to dynamically discover and learn the best path to send the data packets. This type of routing is suitable for larger and more complex networks as it automatically adapts to changes in the network topology. Furthermore, routing can also be classified into unicast, multicast, and broadcast routing. Unicast routing involves the delivery of data packets to a single destination, while multicast routing allows the delivery of data packets to multiple destinations simultaneously. Broadcast routing involves sending data packets to all devices on a given network. Routing is also important for network security, as it allows the implementation of access control policies and the prevention of attacks on the network. Routing devices can use different techniques, such as packet filtering and port blocking to secure the network, firewalls. The term NATAO refers to the translation of the acronym Network Address Translation, NAT. NAT is a technique used in Ethernet-based networks to allow devices on a private network to communicate with devices on a public network, such as the Internet. NAT works by translating the IP addresses and ports of devices on the private network to a public IP address that is used to communicate with devices on the public network. This means that devices on the public network only see the public IP address and not the private IP addresses of devices on the private network. There are different types of NAT, which are differentiated by the way IP addresses are assigned. For example, static IP address NAT, where a fixed public IP address is used for all devices on the private network, and dynamic IP address NAT, where a temporary public IP address is used for each device on the private network. NAT can also be used to improve network security by hiding the private IP addresses of devices on the private network from devices on the public network. This makes it difficult for external attackers to discover and attack devices on the private network. In addition to IP address and port translation, NAT can also include other functions such as dynamic port assignment, protocol translation, and connection management. Dynamic port assignment is used in dynamic IP address NAT to allow multiple devices on the private network to use the same public IP address. Each device uses a different port on the public IP address to identify and track connections. Protocol translation is used to allow devices on different networks with different network protocols to communicate with each other. For example, NAT can translate the IPv4 protocol of a private network to IPv6 for communication with a public network. Connection management is used to track and manage connections established by devices on the private network. NAT maintains a connection table to identify and track established connections and allow data packets to be delivered correctly. NAT can also be used in conjunction with other network technologies, such as firewalls and VPNs, to improve network security and privacy. PAT is a technique used in routers to allow multiple devices on a private network, using private IP addresses, to access a higher-level network through a single public IP address. When a device on the private network communicates with a server on the higher-level network, the router translates the device's private IP address into a public IP address and assigns a unique port number so that the server can send responses to the correct device. It is worth mentioning that the PAT technique is similar to NAT, network address translation, although NAT translates a private IP address into a public IP address, while PAT translates a private IP address and port number into a different public IP address and port number. The router maintains a translation table that contains the private IP addresses and unique port numbers for each device on the private network. When a response is received from the server on the Internet, the router uses the translation table to identify the private IP address and unique port number of the device to which the response should be sent. In this way, PAT allows multiple devices on a private network to share a single public IP address, which helps protect the privacy and security of the devices on the private network. In addition, PAT also provides a certain level of additional security by hiding the private IP addresses of the devices on the private network behind the router's public IP address.